So we welcome today Dr. Chris Dancy from Penn State University. He's the Harold and Ing Marcus Industrial and Manufacturing Career Development Associate Professor of Industrial Manufacturing Engineering and Computer Science and Engineering. And he's the director of the Human in Computing and Cognition Lab. He's a project leader in AI-SDM within one of our foundational thrusts, but his work touches a number of different projects in the Institute. I know he's also working on collaborating with our disasters folks and our adoption and ethics team. So looking forward to a great talk here. Chris, go ahead, take it away.
Thank you, Norm. Thank you for reading out that full title because it's so long that I even forget it half the time these days. Thank you for having me. I'm excited to work to this crowd, especially within the Institute, having an opportunity to really, show people where there might be some connections. Additionally, some additional affiliations up there. And of course, folks, for those who don't know, I am co-lead for the computational representation of human decision processes area of AI-SDM. So I'm really excited to be able to kind of talk within that and show where some of my expertise lies. So whenever I go through these talks, I've really become to appreciate narrative and context. And so I usually like to give a bit of my own context to kind of show how I've gotten on the path I am, which is certainly unique from what I can tell. So I, of course, started, not of course, but I started mostly in computer science. I moved on to cognitive science and AI, especially in grad school, focusing on that. And the time actually just before it became really fashionable to be in anything termed AI, right? I think it's really easy to forget that it wasn't always the most fashionable thing to be in a program termed AI necessarily. And through the graduate study, I came into contact with cognitive architectures as an idea, so systems. And as I was looking at cognitive architectures, a lot of my academic career has been focused on making some very difficult problems only difficult, or when I was a grad student, asking questions that made my own life more difficult. And so I started looking, all right, well, what about, we talk about cognition, what about emotion affect? So I started reading up quite a bit on that and understanding some of the theoretical perspectives there. And I said, oh, that's not hard enough. So I said, all right, well, let's think about the ways these are physiologically grounded. And so I moved on and started thinking through computational physiology as well. And so all of these kind of led to me thinking about how you develop these into computational systems, how they fit together. And so I began to use kind of these individual theoretical perspectives and computational systems to pull together into a system that I'd come to call ACT-R-Phi, ACT-R with some representations of affect, or what we might call emotion, and physiology as well. And so that was hard enough. But like I said, my life is maybe somewhat about making things that are hard even harder. But part of it is interest as well. And so as I started thinking about human interaction, I really also started to think about how individual systems fit and are fit into and affected by sociocultural, historical systems, the fact that individuals operate within and are modulated by social systems in some ways, and of course affect those systems as well. And so I've moved on, or at least added and kind of shifted a bit in looking at critical Black studies and some other perspectives on social systems, sociocultural theory, and thinking through cognitive architectures, cognitive systems, and also how people interact with AI systems in certain ways. And one of the things that I did see from a colleague giving a really interesting lecture a couple years ago for the first time was they had a stack of books behind them, right? They were in person. It was, full on pandemic. We're just getting used to Zoom presentations. And they had a full stack of books and they really went through like, this is kind of what I've been reading recently. I thought that was really interesting. And so I'd like to do that now whenever I give these talks as well. What are the recent books that I read? Now, this doesn't include journal articles and other short things that I've read, but what are some of the books that I've read? Because they certainly will have a certain primacy within thought. And so a lot of it, some of it's cultural studies, some of it's thinking about things cultural history. Some of it is related to disaster response, thinking about how disaster response is situated within those histories, those contexts as well. The work by Medwinter, that Ecologies of Inequity, which is really interesting as a book to read through, and also some reading back to some human-centered perspectives on AI, just to kind of resituate, right? I like to resituate as well with some of these books. And another thing that really is important for my thinking now and the way I think is Sylvia Wynter's work in theoretical perspectives. Sylvia Wynter talks about this concept of the human, right? And I had the human in there, and I think most folks won't represent or won't recognize necessarily without explaining it, right? The ways that I'm thinking about the human is in addition to the kind of cognitive science perspective. And one of the ways Sylvia Wynter thinks about the human is the ways that the human has been dominated in European thought by exclusionary forms of what she calls classical order representations of man. And this comes from a definition from a useful site. And we, a grad student and I talk about this as well. This idea that the biocentric man, as Sylvia Wynter would call it, is characterized by this no one in particular, but kind of a notion of a white middle class cisgender man, genre as a kind of momentary frame or form, a culture or a kind of human, right? The ways basically that we assume certain standards and contextualize are in the AI perspective, our design and development, even if we don't explicitly acknowledge that. And one of the things that Sylvia Wynter does really well is shine light on the ways that certain sociocultural structures, such as racialism, thinking back to Cedric Robinson in one of those books that I showed previously, permeate to kind of essentialize and make things seem biologically natural. Thinking about things like the naturalness or the essentialization of race, even if they actually aren't, natural, but they're very much driven by some other structures. And another kind of foundational thing that's been important for my thinking is some of Victor Ray's work on racialized organizations. So one of the issues or one of the kind of blocks that I definitely had early on in my work is thinking about sociocultural structures from the individual level, right? We kind of have perspectives we can use for the individual level, cognitive, memory-based. Some of it is, is not straightforward, but, it matches what I might expect. And even at the institutional level, you'll see that quite a bit, institutional racism, things like that. But there was definitely a missing part, right? Moving from institutional to individual level and trying to figure out how I wanted to connect those. And Victor Ray's work and paper on racialized organization was a nice reminder of this, middle level of organizations that certainly are important for thinking about the interaction between institutions and individuals. And so the funny thing is, when I go through my journey, non-linearly, I had to think back, and there were lots of questions of organizations and cognitive models earlier on in my career, where I have folks like Jeff Morgan, who's a colleague of mine, who was in Kathleen Carley's lab there at CMU, and he would talk about things like model docking and moving, computational behavioral models between levels. And so this Victor Ray article and some of the related writings were a nice reminder back to that organizational role as kind of a middle ground between the two to help the thinking and develop a computational systems. Another thing that's been really important for me to be able to think through some of this is this idea of levels of cognition. There are, I think, you can have on the categorizations and the ways that this generally is categorized, what fits in well and what doesn't. Of course, this is like a very crude model that models are meant, they will be broken. But it's still useful. This figure really comes from Alan Newell's work in the Unified Theory of Cognition. And then Liautaud et al. Kind of extended it to look at longer time scales, which I think is really useful for thinking about sociocultural systems and think about things on longer time scales and how those live in the knowledge networks, potentially in the individual level, at the organizational level, and through policy, right? And so this is also useful for me for thinking about it from a cognitive perspective and as I kind of morph to think through different levels that do the computational systems I do. So all those things really guide the way that I think, and certainly form a basis for how I tend to think through things. And I think it's always useful to kind of make that as explicit as possible, right? Because that certainly guides the questions that I ask and the way I look at things like human AI interaction. So now that we have all this as a bit of a backdrop, let's move into an example to kind of think through. What I'm going to do is give you this so you can kind of have this as an example to think through as I go through perspectives on my own work as we go through this presentation. So and by the way, I like this example, and if any academic knows, once you have a set of figures that you like, you use them as much as possible because they're so hard to force yourself to make sometimes as a non-artist. So let's say we have this developer, Kelly, and Kelly is developing this AI we come to call Nas. Let's say this AI is, for disaster recovery even. And so they're developing this AI, and the way that, if you went back to maybe my graduate school days and not long after, I might have started out this question with, in saying, I want to understand some of the cognitive processes that Kelly's going to use to develop the AI system Nas, right? Uh, Kind of the typical cognitive science way you might look at it if you're looking at the development process. But my life is about making things harder. So let's add some time pressure on, make it a little more realistic in context, right? Kelly is dealing with the stressor of time pressure because their boss is on them. They want to get this AI done, the system done. Because there's time pressure, because they want to get it finished, they're dealing with very little sleep. So sleep deprivation, which is another stressor to have to potentially represent and contextualize because they're sleep deprived and just because they like coffee. They're drinking lots of coffee, and so they're caffeinated along the way. And because we're torturing Kelly, and let's go back to 2020, 2021, when nobody went out for the most part, and so they can't get an AC person to come fix their AC, so they're dealing with heat stress too. Why not? Let's add that. They live in Arizona desert, and so really, that's a difficult problem, right? Trying to figure out how do you contextualize cognitive systems within all of these integrated stressors. And so some of my work has been focused on creating a system for that. But there's also this slight problem that, the AI itself has been designed and developed, and we can think about deployed and used in existing sociocultural context. So what does that mean? This disaster recovery system is going to be designed, developed, and used in sociocultural particular contexts. And so we can say that AI is going to have to interact with Chris, this theoretical Black man from a financially poor family who is also dealing with stresses, right? How do we begin to really think about all these things fitting together? The individual and also the individual developing and also the individual interacting with that system. And so I start to really think in the work in our lab, what we're really doing is thinking about how do we go about modeling all these factors and how might we understand the implications of this or these models, really a series of models in a simulation. And as we're doing that, we're thinking about structures and systems at the social cultural level that might be impacting and also that are affected by through knowledge and representations and potentially digital environment, AI systems, and people, right? So all these things are kind of interacting in really interesting ways. And it's not that we represent all this within like one simulation, but we start to pick at different parts of this mini figure here. Let's see. Oh, there we go. And so there's different ways to look at cognitive modeling and human AI, and these are kind of the ways that we've been looking at it within the lab. A person in the environment interacting with the end AI system, right? And so we start to think about how the person interacts with, and this could be being supported by, cooperating with, collaborating with, right? Those are all a bit different, the AI system. And so in looking at social cultural systems and knowledge and the way those things might affect that interaction, we've done some work there and we continue to kind of do work there. And then also looking at cognitive affective and physiological processes, which that work is kind of built into some of the stuff in the sociocultural level as well, because we're looking at this from the cognitive architecture perspective. And then from the AI developer perspective, we have kind of a part of our lab working on that as well. How a person designs, develops, and tests, so say engineers the AI systems. And so there's some work that I've done with some colleagues and also one of my grad students is really focused on this, looking at sociocultural systems and the way they permeate in the design and development process. And also I've done some work just kind of looking at some of the cognitive, affective, and physiological processes that might impact those things more directly through software engineering processes. Now, I'll touch on that a little bit as well once we get through it. And so in the end, I kind of come back and think about it all through this figure. And like I said, what I end up doing with the work in the lab, what we do is we kind of look at some of these arrows, not all the arrows all the time. We look at some of the arrows, but we keep this figure as an important reminder of the complexity of what we do to keep us grounded in, what we think we can actually explain with some of the things. And to remember that there's more to do, right, with some of the work that we're doing, and try not to overgeneralize some of the work that we do. And so cognitive, so let's start with this organization with the human agents part, humans in it and the way we look at it. And really, when we look at humans, we look at people, but then when we come back to the computational perspective, we're talking about like affective cognitive models, and typically an ACT-RFE as our kind of grounding architecture to think through things. And again, the architecture you use certainly affects things, and we'll get to a formal definition of architecture as well soon. So when looking at physiological processes in ACT-RFE particularly, we use a system called HUMOD. HUMOD has some nice properties about it, which is one of the reasons why we chose it originally, and we continue to kind of use it. Integrated model, so we get to avoid kind of the micro computational models, more into this idea of having a model where we can look at and see how things affect one another. The top-down organization of the model itself is very nice. What's nice about it is it allows us a lot of times to connect to psychophysiological studies as well as physiological studies directly in the model. And because of that, and because it's open source, we can verify and validate that it works as it says it does, as it should, and then modify if needed. So for example, sleep deprivation is not something that's typically been modeled within the system. And so what I've done in my lab at different times is modified it in certain ways to represent sleep deprivation. But one of the most important things I think that in the research case that is undersold sometimes is this software that works. So you can go in and you can use it, you can play around with it. And of course, it was created a little while ago first, but the versions have been supported pretty well if you talk to the authors at the University of Mississippi Medical Center. And I'll also note that I'll have a slide with references at the end. And if you want, just ask, and I have a whole document with all the references in this PowerPoint as well. The other, nice thing about HUMOD as well is, if you want to explore the physiological effects of, say, a stressor, you can. And so this is an example, a diagram that we ended up making of heat stress. And we were looking at heat stress and the effects on certain behaviors for a project. And so we could just go through, look through the model, look through some of the calculations, derivations that happened along the way, and kind of trace and understand the way that heat stress affects variables in that system, verify that it makes sense, and then begin to kind of, stress it out a little bit to see what happens and understand why those things happen in the system, right? So it's really nice to be able to just understand as a learning tool, but also as a tool just for further models and simulations. So that's the physiological part of the system. Looking at the effect part, what theory really grounds it? A lot of theory from primary process affect theory, Jaak Panksepp, some of his previous work and work that's continued on after these citations as well. We primarily focus on the seeking and fear system within that, and it's a whole thing. We can have a whole conversation about why all caps are there. But seeking and fear system, mostly because those tend to be very well studied, even in different context systems. So seeking appetitive motivation, dopaminergic system, basal ganglia based systems, etc. Fear system, amygdalar based systems, as well as parts like the PAG of the brain. Of course, central versus parts like basolateral, which are a bit different. But these tend to be, very well studied, even if in different contexts. And so those were some of the easier ones, not easy, but easier ones to kind of implement within the computational system, because you have other representations, you have higher level representations like some previous work by Ledoux. And then you also have some useful perspectives where Panksepp is even thinking about this on multiple levels, right? From lower, kind of closer to physiological, more general modulating processes up to what he calls secondary, where he's thinking about things like memory. And so that's, of course, where the cognitive architecture comes in. We can use computational neuroscience work like that by Kent Berridge's lab, where they have their own incentive salience theory, which is similar in some ways to Jacques Paintsup's work, but similar enough, especially in the neurobiological correlates, that we can take some of their work on reinforcement learning, and move it over to and integrate it kind of in the overall theory and use those equations and Tesla's equations with some of the reinforcement learning in ACT-R as a cognitive architecture, right? So we can kind of bring that reinforcement learning physiological drives and bring all that in and think about that within the overall architecture and using some of the representations from VMod as well. We've done that with some other work that I'll reference at some point, even if I won't talk about it directly. And so when we think about this all together, right, we're talking about physio-affective cognitive models. So of course, there's a cognitive part of it, which it comes last, but truth be told, right, I'm starting with cognitive architecture as the basis, which is an important thing to say, right, because that's really the central way of thinking about it, and that certainly colors the way that I think about agents and cognitive models. And if you don't know cognitive architecture, we can define it as a unified theory of cognition, a la Alan Newell, 1990. Is the reference 90? I feel like, yeah, 90, I think is right. There's a later precise paper. But realized as a software system, right? And the realized as a software system is one of those sneaky important things when thinking about cognitive architectures, because the theory might say one thing, but the architecture might have to limit for other reasons, or part of the theory might not be implemented in the architecture and software. And so what that means is the models you can develop, the ways you can think about modeling it when you actually simulate, it's going to be dependent on how things are implemented versus what the theory might say, right? And so that can guide models in a certain way and guide what you choose to model in certain ways. And these architectures, you could say, they posit a set of integrated mechanisms that are used to implement cognition and behavior. And so we might say the way we process information. Another kind of definition and way of looking at it might be that it provides formalisms and knowledge representations that support the development of intelligent agents. Now, it wouldn't be me, and I think my students in some of my classes would yell at me if I didn't point to this definition of intelligent agents and think about a few things. One, because I always kind of emphasize context and history, especially when we think about why we do certain things in AI and cognitive science. And I come back to a lot of times in some of my classes, Herbert Simon's book, Science the Artificial. And one of the things that Herbert Simon talks about is the dislike, or at least the not choosing to have artificial intelligence even as the name for the things people are doing, right? Complex information processing systems, I think, is what they wanted. But of course, we know what won out: AI, right? AI as we see it. So thinking about intelligence and AI, of course, is the term we use. And then the other thing that I'd be remiss if I didn't point out is some issues with intelligence as we think about it and what it means to call agents intelligent agents, right? There's a whole bunch of writing on this from the psychology, cognitive science, and also kind of the AI ethics side of it. The work by Stephen Cave is more on the AI ethics philosophical side of it, but it is a nice short introduction to thinking through intelligence and how the term and the concept is value laden and what it means for the way we think about AI systems. Nice paper, and again, it's a shorter paper, which can lead you to other references as well. But there's quite a bit written on this as well. So one of the big things with my work is, we're using cognitive architectures, and now we've a lot of folks in this area have couched it within this idea of common model of cognition, which is kind of this general agreement that we see from cognitive architectures, kind of what cognitive architectures are doing. I say general agreement that, I'll go into that. So originally we had the standard model of the mind, right? That was the term. Laird, Liebert, and Rosenblum had that in an article back in 2017. They organized the workshop, I think a year later, maybe 2 years later. I think it was actually a year later, around the standard model of the mind. And so you insert a room full of academics at a workshop who argue over standard model of the mind, probably for a whole session, maybe for a full hour, maybe longer. You're probably arguing over, over coffee or drinks later too. And so now we have the common model cognition. So the name changed, but so we couldn't take standard, but we common model cognition is what we call it now. But if you come across that original paper, they are the same thing, really. And the nice thing about the common model cognition is it allows, in the same way that architectures do, it allows you to have this kind of community of researchers around the kind of agreed upon high level model, and it allows you to kind of fall back on some work that other researchers are doing as well, even if they're not in the same architectures, we might call it. And so one good example is Andrea Stocco, who does some really interesting work looking at the neurobiological correlates related to common model and just behavior in general. But he certainly has a kind of cognitive architecture sway to the work he does. And so he found some good evidence for the common model as an organizational principle on information processing, right, in the mind from using the information processing perspective. And so when you use that, then that allows, right, other folks to kind of fall back on some of that work and reference and use it. But if you don't know Andrew Stockel's work there, that paper particularly was really interesting. And so the architecture I use in my work is ACT-R. Has two different names for the acronym, which I won't go into, but this is, again, going back to once you have a figure, you keep on using it. So this is kind of one of the figures I did a little bit ago on ACT-R. My work tends to focus on really the memory system. So the procedural memory system, you can think about it a few different ways. One thing that's useful to point out is this subsymbolic representation, utility learning, really reinforcement learning, and that actually meshes well with some of the affective level theoretical perspectives, and so it's made it a little easier to implement some of those things, especially given the neurobiological correlates already within ACT-R on basal ganglia structures. And so pulling some of the computational neuroscience work into that was not easy, but more straightforward than it would have been otherwise. And then a lot of the work I also do, especially with stress, sleep deprivation, and some of the more recent work is tied around the declarative memory module and understanding how those things might affect some of these processes that are represented in ACT-R and the declarative memory module. And more recently, we're actually moving away from not necessarily using the canonical version of declarative memory. So if you ever pick this software up, right, you get the declarative memory module. Instead, we're looking at using actually another system that simulates some of the same behavior, but using a different representation. So declarative memory there in ACT-R is normally just kind of basically a list of symbols, right, that kind of represent concepts. HDM is a distributed representation instead, representing using vectors. And so this allows us to move into looking at things like language models and other knowledge graphs as big memory systems to integrate with HDM, but it also allows us to look at other aspects of the ACT-R theory a little bit more easily computationally. And hopefully I'll remember to come back to that. Let's go more. And so, again, I won't go into all of ACT-R. We can, that's a whole thing to go into all of it. But if you want a useful, shorter overview, the Ritter-Taranci-Ori paper is really useful. Again, it's shorter because the whole How Can the Human Mind Occur in the Physical Universe book by John Anderson is probably the better historically contextualized one. If you want to look at declarative memory, again, kind of see one that's shorter, but actually is a really good description of declarative memory and some of the neurobiological correlates. Andrea Stocco's et al.'s recent paper. And then for holographic declarative memory, if you want to understand that and the way that works and the way it does match aspects of ACT-R and the way it might be a bit different, Mary Kelly et al. I have a nice paper in 2020 in cognitive science. When we're looking at affecting the motion architectures in general, there's a few different perspectives to use. Coming back to kind of this common model beyond ACT-R. A few in ACT-R are actually two different ones. The work that we kind of do in my lab, and then work that uses theory from different theory of emotion, core affect theory, and then some other architectures, SOAR, Sigma, for example. And we talk about that as well. Some of this, so if you're interested in kind of affect and emotion architectures, the LaRue, West, Rosenblum, Dancy et al. Paper was a nice kind of overview of these different architectures with some references to where you might find more information on these different systems. But they generally represent different levels of emotion and also represent the diversity of emotion theory, right, that exists. And so ActR-Phi is an architecture that works somewhat because of the work that's already been done in ActR on grounding some functional systems within neurobiological correlates. And that helps, right, to ground it with not only primary process affect theory, but also in the physiological, lower level physiological representations as well, right? If we're going to represent a body, we have to understand how, for example, cortisol might be affecting neural structures. And to understand that, we have to understand what structures might be associated with functions within the architecture. So it's been really useful, and that's one of the things ActR-Phi has brought together. So we come back to this kind of example, right? Kind of coming back up, right, on what we're doing and why, and then thinking about this from the human eye perspective, right? We're dive down to the cognitive, and now we come back out into thinking about, all right, what are we actually using this for? And I'll give you some examples of ways to think about, for example, how sociocultural systems of knowledge might affect how a person interacts with an AI system. So we ran this really interesting study. It was interesting to me because I wasn't sure if it would work. I mean, you know, you love those studies where you're like, maybe it'll work, but maybe it won't. And so for this one, it's grounded in a few different perspectives. One of them, A Cave in the Hall, talks about the kind of overrepresentation of whiteness in AI systems, and they make an argument for this in a different paper than the one I referenced before. And so what we wanted to do was look at, okay, you know, is that just phenotypical, or is it really in knowledge networks, right? Is it represented, could we say it's represented, say, declarative memory, and so latent activations of these social structures might affect the way we behave with AI agents. And so we ran this very simple study where the participant has to interact with this AI agent, and they interact with this AI agent to catch a pig. They're just cornering a pig. Catching it just basically means that you're on one side and the other side, so that it can't move. And so we did this little treatment, this very small treatment, which was not meant to emphasize racialization, potentially, at least not to the very explicitly to the participant, but we wanted to see if it, you know, if we could say, well, maybe it activated structures in memory. And so what we did in the treatment was we, you know, went through the instructions and we said, oh, by the way, this AI agent was trained on a predominantly white population. Oh, by the way, this AI agent was trained on a predominantly Black population. You know, oh, by the way, this agent was trained on just trained in the control condition. And so as you can see, if you're looking at this kind of figure to my left, the symbolic view, we didn't do any phenotypical stuff where you might, you know, some you'll see like a Black robot or a white robot, right? We didn't do anything like that because we wanted to see if it was enough to just kind of activate at the knowledge level. And interestingly enough, we did find some statistically significant effects of those, depending on what identity you were, how you identified racially, you did better or worse in different treatment conditions. And you also saw the AI agent as more or less intelligent as well. And this wasn't necessarily associated with your performance. It was more so associated with your treatment condition and your identity together as an interaction. And you know, we have a figure here just to show some of the differences. And we had on the y-axis, we have score. On the x-axis, we have trials. We went across trials. And the big thing to take away from this is we actually saw a very interesting mirrored effect of identity and treatment in this little experiment, where if you identified as, for those who identified as Black, you did the best in the treatment condition where you're told the agent was Black. You did the worst in the control condition. For those who identified as white, you did the best in the control condition and worst in the condition where you were told the agent was trained on a predominantly Black or African American population. And again, the qualitative survey results from that were also interesting, right, on how people thought of the agents as intelligent as well. So really interesting mirrored effect. We didn't necessarily know if it was going to be enough, right? But even without any type of very explicit phenotypical reminder, there seems to be a latent kind of memory knowledge-based effect on it all. And so right now we're doing some of the cognitive modeling to really understand this. And we've also done a follow-up study to kind of expand racial representations as well, and to collect more data, right? Just to have a stronger, even a stronger sample. And in the stronger sample, just the early statistical analysis shows some of the same effects, which we hope to explore in really interesting ways. And so when we're thinking about generally the work going in the lab, when we're doing this, we have that, like I said, that follow-on study representing the model in a cognitive architecture, but also using things like language models and also knowledge graphs to give a world model within that, right? How do we represent sociocultural symbols? And so we can think about LMs or LLMs as particularly contextualized, which is the important point to make, sociocultural symbol regenerators. We have some other work that's NS supported that's considering a wider range of tasks. So we're thinking about how we view the AI and a wider range of theory of AI across tasks, and again, representing the world a certain way. As you might guess, a lot of the work in my lab will hopefully, build upon each other, even if they're in kind of different projects. And then some of the AI, more important for the AI-SDM crowd, right? Some of the AI-based decision support for disaster response work, where we're looking at interaction with stress, representing domain and world knowledge in these models to understand how the sociocultural relations kind of impact potentially disaster response and recovery, DM, and potentially to down the road intervene, encourage more socially culturally aware decision making. And so that's what some of the work with the Pennsylvania Emergency Management Agency, and I'll talk about some of the work extending ACTAR for distributed memory, using this HDM and also using instance-based learning, some of Cody Gonzalez's work within that, right? And so part of this is Cody Gonzalez tends to work at a slightly higher level with decision models. And so potentially, what are these architectural representations at a lower, heavier model level? What does it give us as an advantage, and what are the disadvantages, right? Because of course it's slower computationally, so there are going to be some disadvantages. And so we're working on developing these disaster agents to kind of emulate different perspectives, the individual in something like a mark, and then also so affected by a disaster and recovery, and also the emergency manager. And part of this is really some of the architectural work, which is very big on developing this HDM to work with canonical ACTAR, which it hasn't in the past. And this allows us to process lots of information, a larger corpus than we typically have in ACTAR, and potentially bring domain and general knowledge together. That's one of the biggest things, right? Is bringing these together so we can understand how this world knowledge and common sense, in quotes, knowledge affect the domain knowledge when we're doing these tasks. And in some ways, the nice thing about HDM is it actually works a bit more naturally with instance-based learning than other forms of ACTAR-based declared memory blending, even if IBL was originally situated within kind of this blending system in ACTAR. And again, this is one of those things where if people have questions, we can always answer on the ways that it is maybe a bit more natural. So moving kind of from the individual a little bit more to the higher level, here we go, higher level sociocultural systems and structures, thinking about particularly social systems and structures and AI agents, right? We've been talking really a lot more about the individual and the cognitive aspect a bit more. So coming back maybe a little bit also to the AI developer part, which is a bit more where that part of the work is focused. I tend to come back to this quote from Sylvia Wynter, and the bold part is probably the most important, though you can, of course, read the whole thing. But as well of that of hierarchical social structures in whose intersubjective field that genre of the human could have alone realized itself. So it's really talking about this interaction between the idea of the ideal human and how social structures have kind of impacted that, and then how those things feed together and kind of create a cycle, right, of emphasis. And so what we're doing with some of the work on looking at the AI development process is we're looking at different parts of the AI design and development process and saying, all right, well, how does this kind of genre of the human representation, biocentric man, how does that impact potentially this part of the process? We focused a little bit more on some of the data processing parts because it's a very interesting part to focus on, but you can really go the whole way around any of these parts, data processing, model development, et cetera, and really find some interesting things. But of course, the way we do our work is we kind of zoom out and zoom in to figure out a particular part of that process. Deja Workman is doing some great work within that. And so when we're thinking about these social structures in my lab, we kind of focus on these questions as we kind of move through things and guide through things. One of the big things is how do our social structures enforce a standard? And I say social structures, and one thing you like any student in my lab will know is anytime bias comes up, I tend to emphasize and push them towards thinking about the higher level structures that cause the outcome of bias rather than just focusing on bias when we can. To think about it as a bit of higher level, even if we have to get in and focus on bias as the effect. Thinking about how these structures enforce order or hierarchy, and what does that mean for the development of AI and cognitive systems? What does that mean for people who kind of are outside of that norm in the context of the above question, right? Disaster recovery, we're thinking about that as well, right? What might that mean, and how might we kind of combat that? And in my lab, as you've seen, right, we tend to emphasize racialism, Cedric Robinson's work, and, of course, a Western Euro US-centric context. And then some perspectives on blackness and anti-blackness as well. So when we're considering, thinking about considering social structures, one of the perspectives or what things that we think about as well is how do AI systems kind of perpetuate this racialized environment? And I say interesting is not meant to say positive, but interesting ways. And it kind of creates, right, this bootstrapping process because you have AI systems and bots that are certainly populating our digital environment. And then you have other systems that take the information from the digital environment that was populated by AI and bots. And so you get this really interesting bootstrapping process that happens. And this certainly relates to some previous work, Safia Noble's work on looking at search engines and understanding how they reinforce racism, they're racialized in certain ways. And of course, what's interesting about that from the cognitive perspective is, we can go back to work that kind of tells us or that argues that people have become dependent on these systems in the same way that for their knowledge, in the same way they used to be dependent on friends and coworkers, right? So there's a real primacy in the knowledge and the way we use search engines as our knowledge systems, or now social media platforms. And particularly important because now, even if you're using search engines, as an example, even if, before they kind of had this ubiquitous AI algorithm behind it, depending on your definition of AI, but now a lot of them have very explicit interactions with generative AI systems, language models. And so, of course, the ways that structures represent language models is now coming into contact with this, and that original bootstrapping that we were talking about also starts to have a different flavor in thinking about how they might be really impacting us as a major knowledge source, or for us as people as we use some of these systems. Now, that's the AI part. Thinking about the goals of these systems, also, we can think about the fact that they're defined by people, right? I say human agents. I kind of don't like that, but it's a figure, so I'll keep it. Human agents and that are operating within this environment, digital and otherwise. Even just like 2 hours ago, maybe it was 2 hours ago, this tweet, Gary Marcus had this tweet: the character of the people developing AI and making policy decisions matters enormously for our future. Even if Gary Marcus isn't necessarily my favorite person for Twitter for that, like I think the best are Tindy Gabru and Alex Hanna, for example. But this kind of quote, I feel like a news person using Twitter. This quote, I think sums it up pretty well, right? And I saw it and I was like, I'm just going to capture it because I saw it and I was like, this matches this slide for me. On thinking about how, the AI systems themselves are defined by people, right? We can't forget that. And so with some of the work we've been doing is focusing, again, coming back to this kind of world knowledge and how do we kind of bring in this higher, this conglomerate of knowledge that we have in the digital environment. We've used systems like ConstantNet to begin to explore this. Now we've moved on kind of to some language models as well, and think about them as kind of these knowledge systems to use within architectures. And we're also looking at using ConstantNet and language models together, along with systems like HDM altogether as an architecture to begin to look at not only some of the kind of domain-based models that we might create, but how might those domain-based knowledge models be affected by higher level social cultural structures representation that are kind of latent in these knowledge systems, or what we might think of as knowledge systems at least. And so some ongoing work towards this, right? I've mentioned the cognitive architecture part on software engineering and design, and thinking about that process. Deja Workman's work and thinking about the way the biocentric man is represented in parts of this AI development process. And also, we're hoping to use this as well with an AI-SDM on thinking through and potentially testing AI systems eventually, some of the cognitive models, right? And being able to have maybe more cognitively plausible, sociocultural relevant scenarios in which to test these systems on how people are actually going to use them, right? As opposed to, say, an audit where you're kind of probing it, how might people actually use the systems, and what does that mean, right? What does it mean to use this generative model, have it be a knowledge source? What does that mean down the road, given the representations in say a generative model? And so let's come back to it, right? We have to think about the way that this AI system, disaster recovery AI system NODS is going to interact with many people, including Chris, this theoretical Black man from a financially poor family. Think about questions like how will design for a standard user ignore the sociocultural context of Chris and disaster recovery, right? Going back to Sarah Medwinter's work, or this matters quite a bit. What will it mean if we think about our design of our system in terms of only value and resources, given the relations of the human other? And I have Simon in here, and if I had more time, I would go into the example that I give the class, which is really interesting when you go back and take a critical look at some of the examples provided by Simon in his book, which I like quite a bit, and I come back to. But you always take a critical lens when you go back to it if you can. And then how do we really begin to consider these racialized contexts across various levels? So going back to Victor Ray and some other work, when thinking about how racialization kind of permeates some of these different systems at different levels. And I tend to use it from look at this from a cognitive modeling perspective, and this kind of anchors a lot of what I do and a lot of where my lab moves, even if sometimes we'll kind of go off of that because the theory or the domain of the task might mean that we can't quite fit it into a model quite as well, but it certainly guides the way we think about things. Because, like I said, whenever you have one of these figures and you force yourself to draw it, you use as much as possible. So here's another one just for you, just because I have to use as much as possible. But again, it certainly guides the way we think about things. And so as we're moving through this, yes, to kind of conclude, we're thinking about ways that we continue in cognitive science and AI, but avoid a particular mode of being human. I have the winter references here, but there's also a nice paper by Prather et al. 2022, maybe, talking about it's kind of a letter to cognitive science in cognitive science, talking about the fact that cognitive science needs to represent kind of all people as opposed to a very small subset. How do we realistically engage again with this environment, right? That digital environment that's littered with technological changes and have profound organizing and mimetic effects on behavior, particularly when that environment is changing so much, and some of it is very opaque, right? Some of the search engines, for example, and some of the large language models that people come into contact with change very opaquely because they're hidden behind a company. And so how do we begin to understand this? Looking at Virginia Eubank's work, Sophia Noble's, and of course, Victor Ray's work as well as guiding for some of those thoughts. And how do we avoid developing projects that enact this dominant mode of human and contributes as what we might call a colonizing project and creates systems that support people to be cognizant of these things. And so this is kind of related to this idea that Ruha Benjamin discusses design as a colonizing project. So we're kind of using cognitive architectures as well as we can to kind of think through these things, think through the different aspects and different parts of these processes, right? And you could say ethically way in the general AI ethics realm as well, right? And thinking through some of these things. But since we're at the end, we're kind of close to the end here, yeah. One of the things as an educator that I really like to do is to be able to shout out the folks who are really doing a lot of the work as well. Of course, you saw kind of the different levels I'm straddling and moving between as I think. And the truth is, I can't do a lot of this work unless I have great grad students working on it. Because if I was at the bench trying to do all this, right, doing all the bench work, well, it'd be very hard to get very far because you have to dip in and out. And so the grad students have been great in my lab and undergrads as well. And so I'm going to shout them out because I feel like we should do that more, right? Because they're doing a lot of work and we get the credit. So Deja Workman is working kind of on the AI and blackness. I've mentioned her a few times. She's doing great work. Mira Ray, Carnegie Mellon alum, undergrad, is working on distributed declared memory, holographic declared memory work, disaster recovery simulation work as well with AI, SDM. Swapnika is working on some of my human AI work, the expansion and looking at other tasks related to my career grant. Haya is doing some great work on developing some educational tools for Summer Bridge, Engineering Summer Bridge at Penn State, which is a great summer program for students coming in to their undergraduate experience, on looking at how engineers might use AI systems, because they will, but having to be critical of that and kind of have a literacy as well as they're working with those. Ayush, who's working in the disaster recovery and simulation and modeling side, kind of really doing some of the bench work on developing the models and the simulations. And Dan Ling, who's doing a bit more work with that extended pig chase task stuff, some of the cognitive modeling work, but also some of the statistical analysis that needs to happen along the way. Now, the graduate students had the most pictures, of course, but who doesn't have pictures? Undergrads, none of them, for some reason, decided to give me a picture this entire time of asking them. But we have Alan, the first name there. I told him I would mention him to the seminar because he will be looking for grad school soon, in the next, I guess, year and a half or so. And he does great work. He's doing work looking at dimensionality reduction and how that might impact how we view sociocultural structures effects on AI systems, and also looking at some knowledge graph path-based work within that realm. Great worker, does a lot of work there. Dixon is working with Swapnika on some of the human AI work, doing some great work there, getting us ready to run one of our studies now. Emmy, I won't get a chance to talk on his project that much, but he's doing some really great work on having some critical perspectives on the way universities present DEI data. Sharon, the lone honors student who gave me her picture, is doing some work on human AI use patterns within disaster response and recovery scenarios for AI-SDM. Deeple is doing some work, again, human AI use patterns, but from the public health perspective, right? So we have undergrads kind of doing different work for us. And then Delima is working with Haya on this engineering summer bridge work and creating some AI-based artifacts as well. And so again, I know it was a lot. I feel like it took like 5 minutes. I know it was a lot, but I think, we as educators, we certainly want to prop up our students if they're doing good work, and and a lot of the work that I'm able to do and present is because of them. And of course, also because of my great funding sources, most recently, mostly through NSF and Penn State, a few NSF grants, including AI-SDM themselves, and then some internal funding from Penn State.